We're going to look at problem number 8 from packet number 3, and the packet asks us to find the value of b so that the limit as x approaches 4 from the right of q of x equals the limit as x approaches 4 from the left of q of x. With the limit as x approaches 4 from the right, that means all values that I'm going to put into the function have to come from have to be bigger than 4, which leads us to this second part of the piecewise function. So I can replace the limit as x approaches 4 from the right of q of x, and I can put what q of x is at that point. It's 2x plus b. And I want that to equal the limit as x approaches 4 from the left of q of x. And in that case, q of x is going to come from the x squared portion of the piecewise function. And those are the two terms that I want to make sure they're equal. So I am asking whether the function is, what would make it continuous at 4. So I could take my limit and put in 4 and get, on the left-hand side, 8 plus b. If I put in 4 on the right-hand side of the equation, I would get 4 squared is 16. Just doing the subtraction, b would have to be 8. So we found out that b equals 8, okay? But I want to show you what the problem is talking about graphically. If the function is x squared, the piecewise function is x squared when x is less than 4, then I have the parabola on the left-hand side of 4. It's less than 4, so I have to have a hole there versus it being filled in. And then I have the function 2x plus 8 when x is greater than 4. So that's this piece of the line. But I included the piece to the left of x equals 4 only so that you could see what the b was looking at. Okay, we were finding the y-intercept for the function. Now, the next part of the question is we need to find c so that we make a continuous function. And what that means is I have to find the value that would fill in right there, so I would have one function filled in and the whole thing is continuous. So what does that value have to be? Well, we know that if we put in 4 into x squared, we get 16. And if we put in 4 into 2x plus 8, we also will have 16. So the y value of c has to be 16. So this is the point for 16. When we're looking at continuity, this problem shows that what we have to look at is whether the left-hand side of an equation, the left-hand limit equals the right-hand limit, and I'm pointing those backwards, okay? In our case, both of the limits equaled 16. Which since both sides equaled 16, there is an overall limit which we can write the limit as x approaches 4 of q of x is 16, okay? If the left-hand limit and the right-hand limit don't equal one another, then there's no overall limit, okay? For a function to be continuous, the left-hand limit has to equal the right-hand limit, has to equal the overall limit, and the limit, the overall limit, has to equal the function value. And the use of the term limit, the correct notation is going to be important on these kind of problems. Identifying whether you're working from the left-hand limit and the right-hand limit by using the plus sign and the minus sign are all very important. That's something that you need to get used to, is using that limit notation correctly, okay, and writing it correctly. So if you have any questions about that, make sure that you ask.